Alright guys, I'm going to go ahead and try to do example 2 here for you. Here we have a table, and in tables I like to think of slope as the change in y over top of how the change happens in x. So to do this, I'm looking at the y values and how are the y values changing. And it looks like the y values, it goes down by 6 here, and this goes down by 6 again. So I'm going to put -6. So my change in y is -6. My change in x, it increases by 2 and then goes up again by 2. So that's my change in my x values. My change in my y values over my change in my x values end up giving me a slope of -3. Now I need my y-intercept. A couple ways you can go about finding the y-intercept. When your points, you have 3 points here. When your points are close to 0 in your x, like it is here, then it makes sense to kind of just split the difference and work either down 3, because that's my slope. If I go down 1, go down 3 to -1, or work backwards and add 3. But you can see your slope's going to be -1 here. Another way of doing it, maybe I'll grab another pen. If your points were not close to this x being 0, you could put it into y equals mx plus b form, fill in for y, m, and x, and equation solve for b. So pick any point, maybe this first point here. Your y value is 8. Your slope is -3, and your x value here is also -3. Now, the only thing I don't know is b, and now I can equation solve for that last piece of information. 8 is equal to 9 plus b. Subtract 9 from both sides, and you see I still get -1 is equal to b, my y-intercept. So both methods work. This one only works if you're close to x equals 0. This works no matter what, as long as you can pick out a point that lies on the line. Now putting the two pieces together will give me my equation. So it's going to be y equals -3x plus a -1, or just -1. All right.